This is question number 13. It's another proof coming from the Chapter 3 review. Let's take a look at it. First of all, they tell me that FJ is the base of an isosceles triangle, and that tells us two really key pieces of information. We know that the two legs of an isosceles triangle are congruent, so those two segments are congruent. And I'm actually going to go ahead and put that in my proof. FM is going to be congruent to MJ. If they tell you a base, if they tell you legs, that gives you enough reference. You can talk about other congruent parts of a triangle. So basically, if a triangle is isosceles, then its legs are congruent. Okay, we can say something like that. But remember, your base angles are also congruent. So angle F is going to be congruent to angle J here. Okay. So angle F is congruent to angle J. Two things you could say here. You could say in a triangle, if two sides are congruent, the opposite angles are congruent, or you can just go back to the definition of isosceles triangle since they told us that. If a triangle is isosceles, then its base angles are congruent. All right, we've got that. Okay, by the way, I haven't even looked at anything yet as far as what I'm trying to prove. I'm just listing key information that I need to know. So notice here, they tell me that FG is congruent to JH. Okay, that's that little piece of that segment there, and JH is that little piece of that segment over there. They tell me that O and K are midpoints of MF and MJ. And then they want me to prove that OH, which is this segment right here, is congruent to KG, which is that segment there, okay? I maybe didn't draw it perfectly, but if you look at the original in the book, these two overlapping triangles appear to be congruent, and OH and KG are segments of those two triangles, all right? So I'm gonna try to prove the two overlapping triangles congruent, but we have to be careful because these two congruent sides are going outside of those two overlapping triangles, okay? But I noticed something in the given. Notice they gave me double midpoint statements. And if you think back to Chapter 2, a lot of times when we had statements coming in pairs, it was some kind of a property, okay? So let's look at this. This segment's congruent to this one. That's a midpoint, and that's a midpoint, okay? If two segments are congruent, their halves are congruent, right? That's a division property. So I can say that FO is congruent to KJ, and that's just the division property. All right. Okay, going from there, so I've got a pair of sides on the two triangles. I've got a pair of angles. Be careful, you need full sides and full angles. FG is only part of a side. HJ is only part of a side. I want this whole segment here to be congruent to that whole segment there for those two overlapping triangles. And I can do that by adding GH onto FG, and I can add GH onto HJ. That's an addition property. We're adding the same segment to congruent segments. So I can say that FH is congruent to GJ. That's the addition property. And we're really close to being done now. I can prove the two overlapping triangles congruent by side angle side. Again, if you need to draw the triangles separately, you've got OF and H here, and we've got that side congruent, we've got that angle congruent, and now we've got that base side congruent there, and we can see that we've got a side angle side set up for those two overlapping triangles. So I'm going to say that triangle OFH is congruent to triangle KJAG, and that is by the side angle side rule. And notice that the two segments that I wanted to prove congruent are sides of those two triangles, OH and KG. So OH is congruent to KG. That's what we were trying to prove, and that's because corresponding parts of congruent triangles are congruent. And that's all we need.